The next review topic is on motion. This is when we're talking about particle motion, and we have velocity, acceleration. Remember how the pattern works. Velocity is the derivative of position, acceleration is the derivative of velocity, and so forth. So we have a particle moving along the y-axis, so that its velocity at time 0 is given by this function. We're given an initial condition as well, that t equals 0, at time 0, the particle is at y equals -1. Find the acceleration at time equals 2. Okay, so acceleration at time 2. Well, that's the derivative of velocity at time 2. Now, this would be an ugly function if we had to do it by hand. But luckily, this is the calculator portion. So, you're going to do the derivative of 1 minus, whoops, and it was inverse tan of e to the x at time 2. So negative 0.133. Is the speed of the particle increasing or decreasing at time 2? Well, okay, so I know that acceleration is negative. So I need to see what velocity is happening, which direction we're going in. So let's check the velocity at 2. So that would be 1 minus inverse tan of e to the 2 is negative 0.436. Since both of them are negative, that means we're going in the negative direction. So speed is increasing. They're the same sign. So I would just say, since a of t is negative and v of t is negative, find the time at which the particle reaches its highest point. Okay, so the particle reaches its highest point. Well, that would be when velocity is 0. So v of t, when does that equal 0? And since this is a calculator portion, I definitely would clear out anything else I had and go in and put 1 minus inverse tan e to the x. And I want to find out when that equals 0. So my window doesn't look very good, does it? So let's go to 10. And maybe shrink that down a little bit. Let's try 5 and negative 5. Wait, is that it? Does that look like it's crossing there? Let's find out. 0. I think it's between 0 and 1. It is. Crossing the x-axis at time equal 0.443. So, let's think about what's happening to the left and right of that point. So, when we're between 0 and 0.443, v of t is positive above the x-axis. If we're past 0.443, v of t is negative. It's below the x-axis. So if we went from increasing to decreasing, that means we have a maximum. So the highest point is reached at time equal 0.443. That is a maximum. Find the position at time equals 2. Oh gosh. Okay. And is the particle moving toward the origin or away from the origin at time equals 2? So let's see. We have to know some stuff. So we know that at time 0 we're at -1. We know our starting position. So the position of the particle at time 2, we're starting at -1, and we're adding from 0 to 2 the total position added from 0 to 2, like that. In the calculator, I could do -1 plus the integral from 0 to 2. Oh, I put it in my y1 dx. -1.361. So are we moving away from the origin or to the origin? So since velocity at 2 is negative and our position is negative, moving away from the origin. The next one. So this particle is moving along the x-axis, so its velocity v at any time is given by the following function. Particle at position 8 happens at time 0. Find the acceleration at time equals 4. And if I haven't mentioned it, I forget if I mentioned something or not. These motion problems tend to be number 2s and 3s. These come up a lot. And you shouldn't have any problem doing A and B and C. These are fairly easy. So acceleration is the derivative of velocity. And this is a calculator problem. So you're just expected to use your calculator for that. So alpha. Oh, I did the integral. Oh, goodness. Derivative of, what is that function? Natural log squared minus 3x plus 3. Oh, I should close parentheses there. Dx. Whoops, I'm sorry. When x is 4, I forgot I need to put a value in there. That's 0.714. Find all times in the interval at which the particle changes directions. So let's think about when that happens. That's when the velocity equals 0, right? So when the velocity equals 0, that's going to be when my function equals 0, which I could even find in here if I wanted to. Natural log of x squared minus 3x plus 3 graph. Well, that looks like it happens at 1 and at 2. Look at the table. Oh, they sure do. So that happens at t equals 1 and t equals 2. Those are the direction changes. So let's see what's happening before and after each of those. So between 0 and 1, velocity is positive. Between 1 and 2, velocity is negative. After 2, well, actually it's between 2 and 5, sorry, they did have a limit. Between 2 and 5, velocity is positive again. So we're changing directions at 1 and 2. Particle changes direction at t equals 1 and t equals 2. Over what interval is the particle traveling to the left? Well, it travels to the left when velocity is negative, so it travels left when 1 is less than t is less than 2. Find the position of the particle at time 2. Okay, so we need to deal with the integral, right? So we're looking for the position at 2. We have our starting position of 8 plus the position accumulated between 0 and 2. Natural log of x squared minus 3x plus 3 dx, or whatever, however you want to put it. We have that initial condition in there, 8 plus the integral from 0 to 2, that was ny1 dx, 8.369. Find the average speed over the interval from 0 to 2. Okay, so, average speed, direction doesn't matter. Okay, so over 0 to 2, so we're going to take the integral from 0 to 2 of the absolute value of velocity. And the speed, direction doesn't matter. Divided by 2 minus 0. So we're finding that average, divided by 2. So we could write it that way. And then we could find the integral from 0 to 2 of the absolute value. Whoops. Alpha F2. I know where absolute value is. Where's absolute value? Of our y1 divided by 2. So we're finding the average. That'd be 0.371. These should be some of your easier questions.